here. Okay. Now, so wavelength is your peak-to-peak distance. Okay? So that's like peak to peak. I mean, this peak really gets cut off when the thing hits the wall there, but you get the idea. Wavelength here would be a peak to peak. Well, these are valleys, but the valleys are spaced the same as the peaks. You have peaks and valleys, right?
What symbol is that? Is that? I know
It's a
it's
lambda.
A lambda, okay. That's
Yes.
what I thought it was, but
Yes, I know. You immediately want to start finding eigenvalues, but and this is an eigenvalue, actually. That's one reason we call it lambda. Or maybe it's one reason we call lambda. I don't know which came first, calling eigenvalues lambda or calling wavelengths.
It's like the chicken and the egg, right?
Huh?
It's like the chicken and the egg.
Yeah, I honestly, I'd never thought about that question. Now I'll have to obsess over it for weeks until I find out. Okay. So, I'm not sure anybody knows. At least nobody alive. Maybe I'll have to start visiting mediums and stuff. Do seances and speak to the long departed. But since I don't think that's particularly helpful or valid, I don't guess I'll do it. Okay, well anyhow. Okay, so your wavelength is your peak-to-peak distance. And this thing has to go, what, half the distance of an arc to get one phase of the 4 phases that I've listed here that repeat, right? So this means it has to go 4 half arcs for the cycle to repeat, right? So, well, that reinforces this. Time for the cycle to repeat is 4 times that, right? Well, how are wavelength and frequency related to the speed of the wave? They have to be, okay? Or wavelength and period related to lambda? Well, from this, and this is a little bit of a jump, but it's easy to understand if you just think about it, okay? Okay, wavelength and period, capital T, are related to C how? Well, think about it. C has to equal the wavelength, which is the distance it has to go, which is the distance it moves, right, in time t. Where capital T is the period. Okay? So, as we talked about last time, the reciprocal of the period is the frequency. And that should be something we understand, not as a formula, but as something we really understand in terms of the meaning of frequency and period, right? Okay? So we have this important relationship. Okay, well, how does all that articulate with the other quantities involved with this string, which are its mass and its tension? Okay, if we change the tension, what do we change? We don't change any of these pictures if we change the tension. The pictures are still as they are. What changes?
Your speed.
Yeah, C changes, right? And if C changes, lambda doesn't change unless you change the length of the string. As long as the length of the string is L, lambda is what it is. Now in lab, 2 days hence, we're actually going to change both L and the frequency, or the tension. Okay? And that's going to make a more complicated relationship they're going to try to measure. Okay? But in
So
this,
the tighter the string, the more frequency, right?
in this case, well, that's because we're going to be using a chain of rubber bands, and to change its tension, you have to change its length. Okay? With a string, as long as it isn't a piece of, real elastic string, you can change the tension quite a bit without significantly changing its length. Okay? Or think of a chain. To set up a wave in a logging chain, you're not going to change the length of that chain much at all. Or a steel
Cable.
cable. I was looking for the word, and I just found it as you said it. Okay? Fair enough? So if we change the tension, we change the frequency, right? That's relevant to, say, pianos and guitars. What do you do to tune a guitar?
You tighten it, okay.
You change the tension to get the frequency up to where you want it because your ear perceives frequency.
Right.
Okay?
Never thought about that.
Yeah, that's what's going on. Okay? So the subsequent questions ask you to work in the other parameters of the model, namely the tension and the mass, so that you can now figure out what the frequency would be in terms of tension and mass. Okay? For different modes. The other thing that you can pick up here, and let me just do this in a separate video.